To know a bit why or how Kafka was born, let's look at the history of Kafka. So, very short. In 2008, it was created at LinkedIn. It was subsequently open sourced in 2011, and it graduated from the Apache Foundation 2012.
So it's a top-level Apache project, right?
Yes, so it's just getting to that milestone of being acknowledged as a
Mature solution. Yeah.
yes. So more interestingly, what they were trying to solve at LinkedIn that made the creation of Kafka. So in 2008, LinkedIn was already at several millions of users, and they noticed that there were sets of data that they were not suited for typical relational databases. So when you have actions like modifying your profile or changing a status, that sits nicely on a relational model, and you can use your typical databases there, your SQLs. But they wanted to improve the site by creating a social graph and a recommendations engine based on that information. So that type of data is more associated with how users interact with a site. It's not like discrete actions that happen occasionally.
It's events over time, right?
Yeah. So this is where the event keywords come into play. Now, millions of users using a website, clicking on things and going into links and interacting with the site, that creates a lot of metrics. And that's the kind of the data that was different. Now, all that data that had to be gathered, they needed a solution different from the transactional databases. So they wanted something that had high throughput, that had scalability, of course, and it didn't need to be handled instantly. So what you needed to do is to gather all those events, but then your system needed to be a good buffer for backend that can be bottlenecked by a spike. So if your website has a spike in users, then you're getting a lot of events, and maybe your backend isn't strong enough to handle that. So the solution that they wanted had to be able to store those events in a reliable way, so when the spike goes down, your backend can catch up.
Yeah, makes sense. So let's have a look at the concepts then.
Yeah. So that's kind of how Kafka was born, and then what they did was so let's talk a bit about the concept. So events, we've already talked about them. An event is essentially just something that happens. It can be a measure being gathered from like an IoT device, a thermometer, or something like that. It can be a click on your website. It can be many different things, and they are just they can be simply messages.
Yeah.
And then you have a topic. So a topic is the main Kafka abstraction. So a topic is the place where those events are stored.
So you can have more than one topic.
Yes. A topic is already kind of one of the core ideas. So you can have several topics for different applications. If you have a like a industrial plant, and then you have sensors of different kinds, you could potentially have a topic for one um, type of metrics and a different topic for a different type of metrics. Um, then we have partitions. So let me also show this little diagram here. Partitions are subgroups of topics. So within a topic, you can divide the events that are stored, and you can put them into different partitions.
Mhm.
This can be done to handle your logic around the events in a more like fine-grained way. Partitions can be used to reshuffle data around um, your topic, so it acts as a like load balancing
Right.
system.
Yeah.
Now you have
Well,
replicas.
Is it for splitting up the load so that you can distribute it more evenly across the cluster of systems?
Yes. Yeah, exactly. Then we have replicas. This is a common term in databases. So replicas, as the name implies, they go at the topic level. So you would have your topic replicated several times across your cluster. This provides high availability. So if one of your nodes goes down, then not everything is lost. You can kind of recover because your information was stored somewhere else.
Right. You have more than one copy of the partitions
Yes.
of the topic.
And we have brokers. So brokers, they are kind of the core of the service. They are where the Kafka code runs, and basically, where all the data streams are handled. Worth mentioning that I didn't do so, that Kafka is written in Java. So this is a Java application.
I've also heard of Zookeeper.
Yes.
Maybe you want to talk a little bit about that?
Yes, we can probably go into that through the demo, but essentially Zookeeper is an extra component that Kafka needs, and we will show that a bit later.
Okay.
But yeah, in essence, the brokers, they simply, so you would map them if you have a like a virtual machine environment, you would map a broker to a VM, so you have them separate. And
one broker to one kind of node, VM or server, or
yes. And ultimately, we have the clients. So we talked about what makes Kafka Kafka, but we need two endpoints to send data and to receive that data. So those would be the producers and consumers. They are clients that connect to the brokers. And these clients, they will have access to some topics. And producers are able to write events to those topics. And they can even write events to a specific partition within a topic. And then we would have consumers, which are the other end of the chain. So they would connect and they would read events from a topic. Consumers can also they can read in two different ways. They can kind of be like a watchdog, just listening for new events that pop up, or you can have consumers that just read a part of the log. So remember that the topics are, they're just a log of events. So you can have a consumer that maybe reads the first 50 messages because you want to, I don't know, check that everything is right or things like that.
Yeah.
And with that, so typical use cases for Kafka, basically we need to know how. So first we need to know how a data stream is handled typically. So it would have 3 steps, which, I mean, it's not necessarily specific for a data stream. This is just any pipeline of data. So you would have a first step, which is creating that data. And as we said earlier, you can have that from clicks on your website. You can have measurements being made on IoT devices, or you can have a simply another service sitting that sends you information. Then we would collect that data, and that's where Kafka comes into play. So we would, from all those sources, then we would use the events, the streams to collect that data, and then we would need to process them, so do something with that. So for example, have Spark attached at the end to gather those web analytics and
so
make
Spark is a way to process data streams as well as back data using a big data environment, right?
Yeah.
Cluster. Yeah.
Yes. And so, for microservices, so you could have Kafka acting as kind of a middleware between 2 different services. So
yeah, that's right. So you could use it to pass messages between microservices. I don't know if you have like a microservice for accounts and another microservice for bookings or something. Perhaps you want to pass a message between those 2 microservices. You could use Kafka as a kind of low latency message store for communications like that in ordered sequence.
Kind of like a broker, maybe, of messages as well.
Message broker.
Right. So let's
have a look.
Yeah, let's show an example. So let me share my screen again on a different window. Okay. So for this one, we'll show a deployment of Kafka. So let the deployment. Right. So before going into Kafka itself, just a small comment, Rob, if you want, about what we are going to use to do the deployment.
Yeah.
So,
let's explain that. That'll be good. Yeah. So Juju is it's a systems management framework that Canonical has developed. It's also open source. It's designed to allow teams to do much more, like hyperscale more, with less, right? Less hassle, less team. So it's all open source, and it's designed to drive open source software at scale. So distributed systems like Kafka, not only Kafka, can do things like drive an OpenStack cloud or drive a MongoDB or something like that. So yeah, that's what Juju is all about. It deploys infrastructure and deploys applications, both on Kubernetes and on virtual machines and on real machines too.
Right. So without going too deep into the terminology, so we have charms, which they are essentially operators with the code to administrate something. In our case, we will show these charms, these operators, for Kafka and other components that are needed.
So yeah, the charm is the logic that helps you to do more with less, right? So it helps you to operate the software by deploying it, configuring it, scaling it, whatever you need to do. The charm has the logic in it to help you to do that. It's like a kind of co-pilot for your operations.
Right. So here, what I'm going to show is essentially 3 terminals. So on the right one, we're going to be seeing how the deployment is going. On this one, on the right bottom, we're going to see how the logs basically from that environment. And on the left screen, I'm just going to be running commands.
So you're running these on LexD, right? Which is
Yes.
the kind of virtualization system that Canonical's developed. You can run at scale, or you can run on your laptop. And here, I think you're running on your laptop.
Yes. So here
Juju
was
can
running.
also, yeah, Juju can also work with like AWS or Google Cloud or Azure, so you're not constrained to running just on Canonical technology. You can run it where you need to run it.
Right. So here we just deployed the two operators, so one for Kafka, one for Zookeeper. And I will be showing, since this is running on LXD, I'll show a couple of times the LXD output, just to see that machines are being commissioned on demand by Juju. So I told Juju deploy Kafka and deploy Zookeeper, and then it handles, okay, so I need 6 units, so 6 containers, and we can see them being created there.
So you're using containers rather than VMs. Is that a Kubernetes container?
No, it's so these are
Linux containers.
yeah, Linux containers. So it's based on LXC. So the Kubernetes one.
Yeah, not a Docker container. It's a bit
yeah,
more
images.
Yeah.
And yeah, so
as well.
Yeah,
sorry,
this is a bit sped up because it takes time. It's a lot of machines, but we see that I added Zookeeper, and you mentioned that earlier, so we can just maybe comment on that. So Zookeeper is a storage for metadata. Is another data product that handles metadata, and Kafka needs it to for a couple of things: to store its own metadata and also to handle quorum between topic leadership, to handle replication on topics and all of that. So Zookeeper is being, in the future, Zookeeper is being kind of
phased out, right? It's gonna
yeah.
away, I think.
It's going away in the future, because Kafka is going to implement the craft protocol, which is essentially the Kafka Raft version. And Raft is just a consensus algorithm to handle leadership and quorum changes and all of that.
Right. And it also allows you to store data, I think, as well. We use it in DQ Lite, for example, our distributed database system.
Right. And I think here, I would say, so right now on current Kafka versions, it supports both Zookeeper and Craft. And on the next major version, they will be dropping support for Zookeeper, I believe. So that will be kind of an interval to change all the clusters from using Zookeeper to just use Kafka. The benefits of that is that you don't need 2 different sets of binaries. So the craft protocol is baked into the Kafka binaries, the Java binaries. So that's nice.
Yeah, and we'll match that when that comes. That solution.
So yeah, so we got here already. We have Kafka and Zookeeper deployed. Notice that Zookeeper is active, because as we said, Zookeeper is a product on its own, so it doesn't need to do anything else. It can deploy and you are ready to go. You have a Zookeeper cluster running.
So it's been configured by the Charm to cluster up as a quorum, right?
Yes. So these 3 units are running on a quorum, and the code and the logic to do that has been done by the Charm. And we see that the Kafka, so these would be Kafka brokers that we mentioned earlier. Each one of them would be a Kafka broker. and they are telling us that they are blocked because they require a zookeeper relation.
Yeah, they need to connect to Zookeeper before they can work.
Yeah. So a relation or an integration is just another like Juju command that we can run, and it's a way of having
Also
to,
configuring things, I guess.
yes, to self-configure themselves in a simple and abstracted way from a user. So yeah, the command is run, and then we have a lot of changes here. Because of course then Kafka needs credentials from Zookeeper, and once it gets them, it will create its own internal credentials.
Mhm.
Right.
I can see some errors in the logs. You want to
Yes.
talk about that? I think it's to do with the fact that they're LXD containers rather than virtual machines.
Yeah, so basically we have some tweaks to ccTL properties and things like swappiness, which are recommended. They are the recommended way. Yes. So since this is running on containers, the container doesn't use, well, to put it simply, a container cannot change some parameters like swappiness because it uses the host. So it doesn't have its own
permission.
Yeah. So the charm notices that, but it's not a big problem. It's not recommended, but the Kafka can work with not optimal properties.
That's what we're doing now. Ah.
Right. So once we have Kafka running, we want to get the credentials. And these are just admin credentials because we didn't have any clients being connected yet. So this will be your admin username, your password, and things like the Bootstrap servers. So Bootstrap servers is another small keyword of Kafka, and Bootstrap servers, they are just a list of brokers that when you connect to that list of brokers, it will tell you endpoints where it can serve your requests.
Yeah.
And I think that's it for this demo, and we can go to the next one, which would be 01. Okay. Right. So this is similar deployment. So in this case, it's kind of the same. So we have a Kafka and some zookeepers. They are already related. And from the previous example, at the beginning we only have admin credentials. Now here we are going to use another component that the data platform has created, which is called the data integrator. We use this component to access all of our products. So not only Kafka, this will work for MySQL, for Postgres, for Mongo. So this is a kind of a simple solution to have a way to create users.
So these are functional users within a system. So
yes.
that makes sense.
So going back to that diagram that I showed earlier, we had producers and consumers at both ends of a Kafka deployment. So here, what we are doing is creating a user that can act, in this case, as a producer and as a consumer. And they will have access to the topic named test. So if you wanted to have a deployment with a more like controlled environment, you could have a user that's just a producer, and that user will only be able to produce. And then you can have another user that's a consumer, and it will only be able to consume, and they will both have access to the topic, but they will have like a limited permission set to act on that topic.
Yeah.
We
So
have
I
some.
noticed in the
Yeah.
last demo that you didn't enable TLS, I guess just for brevity and sake of time, but I know that we support TLS as well.
Yes. So yeah, essentially TLS, it's extra applications and extra steps, but
Right.
yeah, we have TLS for encrypting the traffic between your brokers, between in this case Kafka and Zookeeper, and we also support MTLS to
Yeah.
authenticate. So you could set up a client and then have
The client certificate, right?
yeah,
Client certificate basically. Yeah.
change that with the Kafka charm, and then you have a MTLS setup. But yeah, here I'm configuring the data integrator. Again, this is creating another machine, and it will download the code, the operator code into that machine. So here we see that it's telling us, please relate data integrator. And something I didn't mention is, since this works for all the things that we have, here we are specifying user roles like producer, consumer, and topic name. So these are Kafka specific, as we said. If you wanted to use these for other databases, then you would have your own keywords. If you wanted to use MySQL or Mongo, they will have their own keywords that you can provide here, and it will know how to give you a user. And same as we did with Kafka Zookeeper, this is another like relation, another integration between Kafka and the data integrator.
Cool. It's all green.
Yeah, everything active idle. So I deploy another application, which I will go into in a minute. And I forgot to do one thing, which I will be doing now, which is getting those credentials.
Oh yeah.
Yeah, because the data integrator just creates a user, doesn't do. It's used just to have that user creation abstracted, so we can.
This is for systems outside of the Juju world that need a credential in order to interact with the systems. Yeah.
Right. So this is what the data integrator created here. We have a username, relation 19, and then we have some extra information like the password, of course, the topic it has access to, information like TLS, so we know that it's disabled, and we know that its user roles were producer and consumer. So we also can set consumer groups. This is another keyword for Kafka. This is if you want to have your consumers split, or being able just to access different kinds of partitions or topics, you can use consumer groups for that.
Right. I think this is so that you can have multiple consumers that are pulling from the same topic, but then they do it in a coordinated way, right?
Yes.
They don't have some duplicated data.
Yeah. And I deployed here another application. So it's called the Kafka Test App. This is something that you use, as the name implies, to test that things are as expected. So these would be your endpoints. If you want to create, if you have that IoT pipeline, or you have those web analytics, then you would, with the information that we created here for a user, then you would give that to your a kind of business logic.
Mhm.
That can be code in Python. So Python has a library to connect to Kafka, on Java, on whatever resource there is.
.NET and stuff have connectors for Kafka. Everything's got one now,
Right.
more or less.
So in this case, what I'm going to do is just SSH into the container that was created for the Kafka test app. And
you're
inside of
using Juju to do the SSH command, right?
yes. Yeah. So it will automatically alias you to to get into there.
Yeah.
So here I'm going to copy some big commands. We have that on the tutorials. This is just to make sure that Python is available and how to launch our library, our like Kafka library, but this would be dependent on on any application that you wanted to make.
So this is something that you've pasted in here, I think.
Yeah. So we have this client application.
This is from the tutorial, is it?
Yeah, this is from the tutorial. So I just copy pasted. Now I need to change it, right? So interesting things that I need to change: the Bootstrap servers, which essentially they are the Kafka brokers. I will also need to change things like the username and the password with the ones that I got from the data integrator. So I'll be doing that now. And I'm telling the library to produce 10 messages to Kafka to the topic test using those credentials. And I got an error. Now, this error was happened because on the tutorial we deploy 3 units of Kafka, and on this deployment I just deployed 1. So on the command, so it's telling us replication factor larger than available brokers. So what happened is that on the command we have this replication factor here, and it's set to 3. Now we only have 1 Kafka broker, so we cannot do that because there is no other places to replicate to. So we could fix that by scaling up the Kafka application. That's something that we can do as well. You can run a Juju command. Yeah. And scale that Kafka to 3, 4, 5 units. Or in my case, I removed the replication factor. I just set it to 1, which is the amount of brokers that I had. And that's it. We had those 10 messages being created. So this is, just message 9 as a content. This could be all sorts of stuff.
Yeah. Could be your click logs or your IoT device logs or something completely different.
Yeah. And then to make also an example of how to consume those messages, I pass the keyword consumer. I remove all the replication and partition number because we don't need that to consume. And I also added this consumer group. Now, I didn't set up a consumer group, so that gave me an error because we didn't specify any. So we don't need a consumer group in this case. That's something else you can specify on our on the data integrator. So in this case, I removed it, and there we go. We consume these messages.
Right. So those are the messages that you loaded into Kafka.
Yeah, those are the messages that I loaded earlier.
Okay.
And in this case, just to see, so in this case, there was like a heartbeat, which means that it was kind of waiting there for more messages because you can subscribe to.
Yeah, so keyboard interrupt, that was you hitting Control-C that caused that.
Right. And that's the 2 demos. We have time, so I have an extra demo of something. So let me share again. should be good. Yeah, there are the flowers. So yeah, so here this is not recorded. This is live on my computer. So what I have here is an extra example of how to use metrics. So of course, when you deploy any kind of service, you will want to have some metrics.
Yeah, you want to be able to observe what it's doing, check it's up.
Yeah, let me make this a bit bigger. So here, what I have is Kafka and Zookeeper, and I have some extra stuff, which is called the Grafana agent. So we also have on like as extra components, we have integration with the observability bundle, which is another product that
observability stack.
Yes. If you want to give just a small explanation of the observability.
Sure. Yeah, so it's so our canonical observability stack, it's based on open source software again. So it's based primarily on Grafana and Loki and Prometheus. So it gathers logs as well as metrics. And also you can set alerts. So it has alert manager in there as well, so that you can be alerted if your machines are, I don't know, disks are filling up, or utilization is going above 80%, or whatever the concern might be, or something's failing, or processes are continually restarting perhaps over 5 minutes. It's pretty powerful. Let's have a look.
Yeah, and this is the example of the observability stack, just to show you that it exists somewhere else on the. So this one is running in Kubernetes. So what I'm showing here is an observability stack running on Kubernetes that's connected to a local. Both of them are locally, but another deployment, and this one is running on LXD. So we have cross substrate integration as well.
Cross cloud.
Cloud, yeah.
Yeah.
So here, this one is using the local host, so the LXD, and we can see that there are some offers, some endpoints that we can use, the Grafana dashboards, login, and Prometheus scrapers. So this is another relation, another integration that we have, which is with the Grafana agent.
Yeah, so I think the reason why it's on Kubernetes is so that it's isolated from your actual workload, so that if your workload went down for some reason, like the environment went down, your monitoring system doesn't go down too. Not necessarily. There's not an inevitable relation, a close relationship between the two environments, so that you can still receive alerts that your system went down, right? That's why it's like that.
Yeah, and well, just to show here on this works the same. So I can run on the Grafana. I can, same way we did for Kafka and for the data integrator, I can get the admin password. So it's this one. I have already running it. I'm already running it somewhere else. So let me go back here. Where are you? Here. Well, spoilers. I didn't want to show this from the get-go. But yeah, this is kind of the. So we are here logged into the URL of Grafana that we exposed already, and then here we have dashboards. So there are some dashboards that the observability bundle gives us, and then we have some that are imported automatically from our Kafka operator.
Yeah.
So
there's nothing the user has to do apart from integrate Grafana with Kafka, and the dashboards are available in Grafana.
Yes. So this is out of the box after the integration is done, which is it's nice. I have some messages here because I was making some tests, and I can actually do that if I run. So the Kafka test app has a an action, run Kafka test app, and I can start the process. So I have all of this done, but it's essentially the same. In this case, for the sake of being a bit faster, I'm using admin, but let's say topic name 3, and then it will start to create messages for that. So if we go to Grafana, we should be, yeah, we should see a spike here at some point. It will take a bit of time, but we will see. Well, while it starts to gather those metrics, we can actually show something else, which was the alerts, which also exist here.
Oh yeah.
This is something else that we have.
These are all alert rules, right?
Yes, so you can have alerts based off. So remember that Kafka is a Java application, so you can have alerts based on memory usage. You can have alerts based on, I don't know, under replicated partitions and things like that. So a lot of things, this can be changed and made custom. So there are some for Zookeeper as well here, JVM memory. So yeah.
Cool.
So going back to the dashboard, I think it should be. Yeah. Okay.
Oh, look there.
We're fine. So we see that the number of topics increased and to 4 from 3 to 4, and we have a spike here on messages in. Latency. I mean, we have a lot of metrics. But, yeah. And
cool.
I think that would be it.
Should be enough, I think. All kinds of awesome. Thank you for showing us around, Raul. So I see that there's a few questions. There have been a few. So now's the time to start to answer those, I think. So one question. So if you have questions, feel free to type them in now, and we'll try to get to them. So one question I see is a broker a kind of a server? Kind of server. So
yeah,
I mean,
yeah.
Well, it's a daemon process, right? So it's a service that runs on the server. Yeah. So typically there's like one broker per, one server per broker, and it's just running that process and not much else. Like that's typically how it would be set up. You could run other services on there too, but like for Kafka, you generally want to have just the whole server doing just Kafka. And then I see another one. Is Kafka going to be a snap? So I think the answer there is we have it as a snap. Yeah, yes, as a part of the Charmed solution for running on cloud infrastructure. If you want to run it on Kubernetes, it's not a snap. It's a container image. So that's how we deliver it. It's either as a snap, which is delivered as part of the solution, or is delivered as a container image, which is also part of the solution. So you get like full support on that. We security maintain the distribution of software inside the snap. So we bug fix it, and we also fix CVEs on that. And then I see some more questions. So what is the Juju command all about? So it's maybe somebody that tunes in a bit later. So we talked about that a bit earlier on in the demo. So Juju it's like a operations management framework that Canonical has built. It's open source. You can check it out. You can play with it for free, and you can modify it too. So Juju is it's built in Go. It's designed to allow you to manage hyperscale infrastructure. So you can use it for like clouds, for applications. So it can drive OpenStack. It can drive like Ceph, distributed storage systems. And in this case, we were showing it driving Kafka. So it can also drive like Kubernetes applications on Kubernetes too. It's pretty powerful, and it does the full stack. And it's designed, to allow you to do like more with less, Okay. Is the Grafana provisioned by Juju as well? Yes, it is. Yes, so it's all provisioned and driven through Juju. So I think Raul showed like another environment that he built using Kubernetes, where Juju had deployed the full like Grafana, Loki, Prometheus alert manager stack. And then there's more. So can you have alerts based on garbage collection? Yes, you can. Yes, you can. I think he even showed that, no? In the Java
So
metrics.
and an extra note on that, a normal deployment of Kafka will already have the JMX exporter. So we already have an extra endpoint to gather all the metrics that Kafka exports. So the mbeans from Java, basically.
Right.
So, and that can be also tweaked, which segues into the next question, which is if we can track Kafka metrics, such as number of messages in particular time window. Yes, with Grafana. Yeah, so no, I don't think I changed the time window, but you can change the time window when you want. So Prometheus, Grafana, Loki, they will store all your metrics until your disk space runs out if you don't rotate things. So you can go back in time as
right.
As back
so
as well.
Let's see, I think there's a couple more questions here. This one's a long one. It's about Kafka users. So the question is about whether the users are recreated dynamically on the fly and assigned new usernames. I don't think that's the case. Don't think they are. I'm pretty sure they're not. So I think that the passwords and usernames are stored. So I don't think that would happen. I think unless you had a total loss of your environment, but then I mean, yeah, you're going to have to rebuild. But in the case where there's an outage and Kafka restarts, I don't think this would be an issue.
Well, so just to provide a solution there, if you don't have integration within Charm, so if you didn't build a Charm, so you're just using what we showed, which was the data integrator, and your program goes down, you can unrelate, and integrate again, and that will recreate your passwords, and that can be done by any kind of command line that you may have. So there are ways into it, but yeah, once you exit kind of the Juju space, you need to actively act on that, because that would be the same for for a situation where you are just using Kafka. If your client goes down and it doesn't, Kafka will not know that it needs to drop that user by default. So this is kind of the same.
There's another way around this as well, which is we support MTLS. So if you're using certificate-based authentication, I mean, the certificate's not going to change. Okay, and then there's another remark about performance of Kafka on Kubernetes and Docker. So we don't support Docker, but we do support Kubernetes. Yeah, I mean, like I wouldn't personally recommend running very high scale workloads for Kafka on Kubernetes personally. I think it's fine for some use cases, but not for all. Okay, I'm checking back. Can you please explain further the relation between brokers, topics, and partitions, and how it manages redundancy? Yeah, so you have a broker. So you have typically you have 3 or more brokers in a production deployment. And then you'll have a topic, well, more than one topic. You have many topics. So a topic is like a logical grouping of events or messages, and then those topics are partitioned in order to allow for scalability, right? So it's basically like sharding. The partition, if you know what sharding is about, that's the same. So it allows multiple producers to write concurrently at scale, and also consumers to read concurrently through partitioning. There's also replication, so that you have a copy of each partition replicated like 3 times over or more. You can specify how many times, and that can also help with performance and resilience. Like, so if one of the brokers goes offline, the data is still available and online on one of the other brokers or 2 of the other brokers. I hope that gives some clarity there. And then there's another question: how do we understand Kafka and Flink? When to use what? Do you want to take that one, Raul?
I'm not too knowledgeable on Flink.
Okay, I can do it. So Flink is very similar to Spark. So it's a framework for developing streaming data processing applications. It's a great way to build producers and consumers that write data to and from Kafka and process it. So you can use it to, for example, take data off a topic, do an aggregated calculation on that data, and then write it back to another topic. So if you have an event of something over time, I don't know, temperature over time, and you want to aggregate that into average temperature over time, you could use a Flink job that runs continuously next to Kafka to take data from your temperature over time topic and write it to your aggregated average temperature over time topic, for example. You could do anything else that you might want to do as well. So you could use it to take data from Kafka and write it to a data lake or to a database like MongoDB as well. So you're not constrained to just working with only Kafka. It's a very flexible framework for doing what you need to do, right? It's very similar to Spark. So another kind of interesting nuance here is that with Kafka and Flink, you can do kind of end-to-end guaranteed exactly once delivery. So that means that you have like stuff that you write to Kafka, and it only gets written once to the destination, and it's guaranteed to be delivered once and only once, which is quite a nice feature with Flink. But they are semantically quite different in terms of what you're trying to do with them. So Flink is there to really to process data and do things and move stuff around. Kafka is there to hold data. It's like a storage for data. Yeah. Okay. So I think we're at the top of the questions, more or less. So thanks very much for your time and for listening and watching. And I hope that was helpful. All right. Take care. Have a great one.
Thank you.